So thank you very much, Linva, for being able to give the second talk for the beginners series. Most of you will probably have heard Linva speak before. She's a member of our association, but she's also a very well qualified beekeeper at a national level as well, and an excellent speaker. And we look forward to this talk on the colony and the queen, Linva, if that's okay.
Yep, and also just to say before we kick off, hopefully you've all received notification of the Welsh Beekeepers Association webinar tomorrow night at 7 o'clock, and Wally Shaw is talking about swarm control. So if you haven't already had the opportunity to register for that, I believe there is still time. So I'm sure if you contact Anne, she can forward you the details if you haven't already received it.
Okay, I'm just going to mute everybody, Linva, and then you put you back on.
Righto.
I want to unmute Linva. Oh, here we are.
Good. So hopefully you can hear me. Yeah, Helen's putting the thumbs up, so that's a good sign. So I shall continue. Right, so tonight we're thinking about the colony as a whole. There's quite a lot of information here, and it's always really difficult to give a beginner's talk because it's really hard to resist the temptation to run before you can walk. So bear with me, and if there is stuff that you don't quite pick up on or you don't quite understand, don't worry about it basically, because as you learn more about beekeeping, it will all slot into place. So don't worry too much if there's a few details that don't quite make sense at this stage. It's just really hard not to mention them, because otherwise there'd be big gaps in what I'm talking about. So anyway, we'll kick off and we'll see how we get on. So basically what I want to talk to you tonight is about some of the basics of beekeeping and some of the information that's really crucial for you to understand, so that when you open a colony and you see a frame of bees like we have in front of us here, you can start to understand what you're seeing, and then that will influence the decisions you make about managing that colony. So just by looking at this frame of bees, there's actually a lot of information it's sharing with us in terms of how the colony is doing, maybe what time of year it is, whether they're queen right, whether they're brood rearing. And this is all the sort of information that you need to know in order to manage your colonies. So starting at the beginning, what we would expect to see in our colony of bees is many workers, a queen bee, and some drones. And this would be typical at this time of year. So we'll have a bit of a delve in a bit more detail about each of these. So thinking about the summer now, so at this time of year, I don't know if all of you have colonies of bees yet, but if you do, you would be expecting at this time of year to have approximately 60,000 worker bees inside a full-size colony. You would expect to have one queen. There are situations where you might have more than one queen in a colony, but we won't go there for now, okay? So let's just work with one queen. And at this time of year, you'd expect to have approximately 2,000 drones. Now, in the winter, the situation changes quite dramatically, and you may only have approximately 10,000 worker bees, still only one queen, but in the winter you have no drones. The drones are just too expensive to overwinter. It's not in the colony's best interests to try and feed those drones over winter, so they actually get rid of them in the autumn. It generally is a very expensive on resources for a colony to overwinter, and that's why they reduce down in number so greatly, so that they have hopefully got a better chance of getting that colony through the winter. Honeybees are quite different to many of the other social insects in that they do overwinter as a colony, whereas, for example, wasps and bumblebees, it's just the queen that overwinters and all the workers die out, whereas honeybees are different and they just contract down to a smaller colony to get through the winter. So let's have a little think about the different castes and sexes within the colony. So the picture on your right is an example of some worker bees. These are all female on the frames within the honeybee hive. The picture on the left is a drone. So these are the male bees. And like I said, there's about 2,000 of these in the colony. You can see that they're quite chunky little things. They have much bigger eyes. They have a much bigger thorax, which is the part that the wings are attached to. And that's because it houses the flight muscles. And then their abdomen is much hairier than the worker bees. This is a worker bee. It's difficult because these pictures aren't to scale, so that's not tremendously helpful, but she's a much more svelte and much more kind of athletic looking and just very busy. This is slightly better scale-wise. It's not perfect, but now you can compare the size of the drone with the queen. So this is the queen in the middle of the picture there. You can see she has a very long abdomen, and then the bees around her are female worker bees. So you can see that they are smaller than the drone and the queen as well. And that just gives you a rough indication of the size differences. The queen's abdomen is so much larger than the workers because this contains her ovaries, and she essentially is an egg-laying machine. That is her role, is to lay eggs, because that's what produces all the bees to be able to then continue the colony. So by castes, we mean we have two female castes. So we have the queen and the worker, and then by sexes, we have male and female. So male is the drone, female is the worker and the queen. So as I mentioned, the queen essentially is an egg-laying machine, and you'll hear beekeepers referring to brood. We're just obsessed with the brood and what's going on in the brood box and within the brood nest. And this is because this is where all the bees are being produced. And to be able to produce you a honey crop and also themselves a honey crop, because don't forget, bees are actually there to look after themselves. It's just lucky that they manage to produce excess honey and we take that bit. But their ultimate goal is to produce enough honey to be able to last them through the winter so that they can start again next season. So they need to produce a lot of brood. And by that, I mean eggs produced by the queen, and then the workers rear these eggs and feed them with brood food to produce the larvae, and which then go on and pupate to become the bees. So essentially what's happening within a colony, most of us, when we were in school, we learned about metamorphosis in frogs or butterflies. Well, this is exactly the same process. You start off with an egg, it becomes a grub or a larvae, and that pupates, metamorphosis takes place, and out pops the perfect bee. So that's what's happening within the colony all the time, but to quite a vast extent and to quite a high turnover rate. So there's constantly new bees being produced all the time to provide a continuous supply of workers to go out and forage for the honey. So let's just take a bit more of a look at the females, so the queens and the workers. As I mentioned, we have one queen in the hive, and we have many workers, as I said, up to 60,000 at this time of year. What's interesting about the females is they're all produced from exactly the same type of egg and larvae. So there's no distinction between an egg that's produced for a queen and an egg that's produced for a worker. The difference comes in the very early stages of that larvae, in the first couple of days, when the bees feed it. And if they need to produce a new queen, they will feed it to excess. and they feed it on royal jelly as opposed to brood food. You've probably heard of royal jelly. It's actually harvested in some countries and used in health food products. But it is a superfood to the extreme. And by feeding those larvae on this superfood, this royal jelly, then it switches on the genes within that larvae and turns it into a queen rather than a worker. It's basically magic. So in order for this to happen, for the bees to be able to produce queens, then they need to have a very well-fed colony, and they need to have plenty of nurse bees, and the colony needs to be stimulated to produce those queen cells. So I'm just including this information for completeness, really, but I'm not going to go into this in any detail. Talking about why bees produce queen cells is a talk in itself. So just for you to know, bees can produce queen cells, and in order to do that, they feed it a super rich food. That's where we'll leave it for today. Now, these queen bees, they're capable of living for 3 to 5 years. You'll always come across someone who's got one that's 7 years old or something like that. But in a beekeeping context, from a management point of view, we tend to replace our queens every couple of years. And the reason for that is we want a queen who's young, who's vigorous, and is very prolific in terms of the number of eggs that she's able to lay. And obviously, younger queens are better at that. So that's why we'll be looking to replace our queens, maybe on a sort of 2-year rotation. Now, the queen mates early in her life, and she only mates once. Well, I say once. She can mate with up to 20 drones, but it only takes place in the first couple of weeks of her life. If she runs out of sperm, say when she's 1 or 2 years old, she can't go out and mate again to top up her sperm reservoir. So it takes place in the first few weeks of her life. Now, she's anatomically different to the other females, the worker bees, in that she has very large ovaries. Worker bees also have ovaries, but they're very much smaller. They're kind of like a vestigial effort, really. And they can lay eggs as well. Again, we won't go into that now. So that's why she has such a large abdomen, is to house these enormous ovaries. Now, the queen bee also characterizes the colony. So by that, I mean, she produces pheromones. They're chemical signals that the worker bees share throughout the colony. And so they know she's present, and they then know that they're working towards this complete colony. Honeybees operate as a superorganism. They don't work for themselves. So having that queen providing the cohesion within the colony gives them a task to do. And that queen will be laying eggs that produce the new workers and the drones, and then if that colony decides that it needs to rear a new queen, then she can provide eggs for that as well. After she's mated and is settled within her colony, the only other time that she'll leave the nest, so the hive, so to speak, is when swarming takes place. Again, that's a topic for another day, but just for you to know that the queen will always stay within the brood nest unless the colony swarms. So this is the sort of information that most people kind of gloss over, because generally people are quite bad at remembering timings and dates and things. But actually it's quite useful if you can learn this. So don't worry if you don't remember it all today, but you know, over time, this is the sort of thing that perhaps you can come back to and try and remember. So thinking about how a queen develops within a colony, the egg is laid in a cup, so in this picture, you can see the horizontal worker brood, which is what the bees are walking over. And then at the bottom, you can see this little, well, I say at the bottom, it's actually at the top of the picture, but it's on the bottom of the frame. You can see this cup. And so eggs that are going to develop into queens are laid in cups that are vertical rather than horizontal. So that egg is laid, and then it takes 3 days before it hatches into a larvae. The worker bees then feed it the queen royal jelly, and they produce this royal jelly in glands in their heads. And that royal jelly is produced from huge amounts of pollen and some nectar. Pollen is a really important feed source for bees. We always tend to think of nectar as being their food source, but pollen is equally, if not more, important. So they'll feed that larvae then for 5 days. And during that time, the workers will visit those developing larvae to provide food approximately 1,600 times. Compare that to a worker larvae that's developed, and a worker larvae gets approximately 150 visits to provide it with food. So that gives you an indication of the magnification of feeding that's required to produce a queen rather than a worker. Now, hopefully this picture shows a little better what I mean by these vertical cells rather than the horizontal cells of the worker larvae. So at the top of the picture where the bees are walking, that's the worker larvae that are pupated and developed within those cells. And then these cylindrical cells that are hanging downwards, within these that are developing queens. So they get sealed into those cells on approximately day 8. So when I say day 8, day 1 being the day the egg is laid, and then the development takes place and the pupae develop. And during this time, that's when those different proteins switch on the genes that turn that enable her to function as a queen. So then after 16 days, the queen will emerge from this cell, and at the bottom of the cell you can see this ragged edge, and that's where the queen has chewed her way out of the cell and released herself. So the thing to remember is from the day the egg is laid to the day that she is released from that cell takes 16 days. And the reason this is important is this will help you manage your bees when they're thinking about swarming, because you'll understand the timings of when swarming will occur and when that colony could leave the nest. And also it's really useful when you're queen rearing as well, so that you'll know when you can expect to have new queens within your colony. So once that queen has emerged from that cell, it'll take her approximately 4 to 7 days to mature. So during that first week of her life, she basically just wanders around within the brood nest. The bees feed her, she doesn't feed herself. And then she's basically just matured up and her ovaries have matured a bit more. And so then she's able to go on mating flights. And within the first 3 weeks of her life, she'll leave the hive and she'll go on 2 or 3 mating flights. While she's out on those mating flights, she'll mate with approximately 20 drones, and then she returns to the hive, settles down, and then she starts laying. And then that's the start of her productive life. Just to note that mating in honeybees takes place in the air. So basically the virgin queens go out on mating flights. They release pheromones as they go, which attracts all the drones which are up in the air, and the drones chase after her and mate with her. So it's a really precarious situation. they can easily get predated by swallows or any other bird. So it's a real miracle that you know, 9 times out of 10 they seem to appear back in our hives and produce us a productive queen. So once she's up and laying, she'll be laying up to 2,000 eggs a day. This is, you know, an absolutely huge undertaking for her. It's more than her body weight, and she needs to have a really high energy food provided to her, and it's the workers that feed her constantly while she's roaming around laying in all the empty cells. And her egg laying is very much controlled by food intake. So over the past couple of weeks, we've seen some quite interesting situations. While the weather has been very good 10 days ago, as it became drier and drier, the nectar sources dried up. And so there would have been a lot less food coming into the colonies. And then, of course, we've just had the last 4 or 5 days of subarctic weather with rain. And it's probably knocked our queens off lay. So don't be surprised if you go into your colonies at the moment and there doesn't appear to be a huge amount of brood. Hopefully you'll see that pick up now as the weather warms up. The bramble is starting to flower, so there is forage there available for them now, and hopefully you'll see the laying rate of the queen pick up. Now, what's also quite nice to see when you see your queen is quite often as she patrols around the combs, you'll see her constantly surrounded by bees, and you can see in this picture where she's surrounded by a circle of bees all facing her, and we call this the Queen's Court. What they're doing is they're feeding her, so you can see the bees nearest her head are actually touching her with their tongue and their antennae, and they'll share food with her. They also continually touch her body as well, with their antennae and their front legs and their tongues, and they pick up the pheromone scents from her body, and then they'll exchange that with bees around them, and so gradually the scent of the pheromone gets passed all around the hive and within the brood nest. And that's really important so that the bees know that she's present. And actually, if you take a queen bee out of a colony, within 10 to 15 minutes they'll know. And they'll all start fanning at the entrance to the hive, trying to guide her back in because they think she's maybe gone outside. So now we're just going to think about the worker development. So the worker bees, they also start off as an egg laid in the cell, and that also takes 3 days to hatch. They're fed brood food from the worker bees. The other worker bees feed these larvae brood food, and they're fed that for approximately 5 days before those cells where they're developing are sealed over with this layer of wax. The cells are almost horizontal and are back to back. So if you look at a cross section through the comb, you'll see 2 cells back to back covering the frame. So there's, you know, a couple of thousand cells on each side of each frame. I'm not sure I've explained that very well, but hopefully you know what I'm talking about. So once they're sealed in the cells, the larvae pupate, and then after a further 12 to 13 days, they emerge as the adult bees. And this whole process for worker bees takes 21 days, so a little bit longer than the queens. And this is a typical slab of worker brood. If you look in the top left-hand corner of that picture, you can just see the white C-shaped grubs of the developing larvae. And as they get a little bit bigger, and then on approximately day 5, after the egg has been laid, then they get sealed over with this layer of wax to protect them while they go through this pupation process. So now onto the development of drones. These are the male bees, and their eggs are laid in slightly larger cells. So if you look at the picture in the top right-hand corner, in the far left-hand side of that picture, you can see the very even cappings of the worker brood. Looked very much like the picture on the previous slide I showed you. But the rest of that picture is taken up by what we call drone brood. And that's much more, it's much larger, it's kind of raised up and a bit more knobbly than the worker brood. And that's because the drones are bigger than the workers. You can see that in the picture at the bottom of the slide, with the drone being the large bee in the middle. And so they need slightly more space to develop. So once again, the egg is laid, and that takes 3 days to hatch. They're fed brood food for a further 6 to 7 days before that egg, cell is sealed over, and then pupation lasts for 14 days. So their development takes 24 days, a little bit longer again, and that's just down to the size of them. So the adult drone bee, once it emerges from those cells, takes about 10 days to mature, and by mature I mean become sexually mature. The drones have one real purpose in life, and that's to mate with virgin queens. He'll live in the brood nest during those 10 days that he's taking to mature, and he just wanders around the brood nest, stealing food and just generally hanging out and having a nice time. Once he's mature enough, he'll start taking regular flights, and during those flights he's going out and he's looking for virgin queens to mate with. If he doesn't get lucky, he'll return home. If he does get lucky, he actually dies during the act of mating. So it's quite a sacrifice he makes. So if he does die during mating, then obviously that's game over. If he doesn't, then he just keeps returning to the hive and will try again the next day. If he never gets lucky, then come August, September time, the bees will just evict him anyway. As I said at the start of the talk, it's just too expensive for the bees to overwinter these drones. They'd consume far too much food. So they actually evict them from the hive, and the drones all die off at the end of the season. So this picture here just demonstrates as well the difference between the worker brood on the left-hand side, where most of the bees are walking, and it's very even sort of cappings, and then the more raised knobbly cappings of the drone brood. And it is quite easy to spot. Once you get your eye in, you'll clearly see the difference between these on the frames, and it's just quite useful for you to know the difference between the two. So this is just a summary now of the larval development time. So the numbers across the top are days. The top line are the workers. Remember that the workers and drones are actually horizontal, not vertical as it's depicted in this image. But you can see the workers are an egg and for 3 days, and then on day 3 you can start to see the larvae, and then on day, well, it's roughly day 8, day 9, those cells are sealed over, and then pupation takes place, and the bee undergoes the molting, 5 different molt stages before it develops into this worker bee that can then emerge on day 21. And the drone then, a similar process, but just takes a bit longer and emerges on day 24. And the queens, remember these are vertical but hanging upside down, and the queen egg is laid on day 1, the larvae emerges on day 3, and then the cell is sealed over by day 8, and then on day 16 she emerges. So, you know, while it might just feel like a lot of numbers, it is worth learning this, and that will become clear as you go through your beekeeping experiences and start doing different manipulations and management. It's useful to know what you're seeing and at what stage it is. So it's also worth remembering that the bee's nest, so its colony, where all this brood rearing is going on, is actually a cross section. So imagine each of these frames. I hope you can see that this picture is depicting a series of frames, and this is a cross section through them. So in the middle we have the eggs, and then the larvae are surrounding those eggs, and then the sealed larvae is the darker shading, and then round the edge of that you'll have the pollen, and then some honey stores around the very outer edges. But of course the different stages of egg, larvae and sealed brood will change, because as the eggs develop into larvae, and then the larvae develop into sealed brood, and then the sealed brood emerges, and so then the queen will lay eggs where the sealed brood was. So you have this constant flux. So, you know, in 3 weeks' time, you'll see eggs on the outside and sealed brood in the middle. So don't worry if you don't see exactly what I'm showing you, because there is obviously, you know, this flux and change as the cells develop and change as they go throughout the life cycle. But just remember that it is a cross section, and these combs bisect through this brood nest. So this is also quite important, and that's to understand how the numbers of bees within a colony changes throughout the season. So starting in January and February, as I mentioned, they overwinter with approximately 10,000 bees in the colony. And actually, as we see milder winters, we actually start to see the number of bees increase, probably by mid-February, early March. And so then you'll start to see the queen's rate of laying increase. So she lays very few eggs over winter, and then it'll start to increase in March. And then as those bees emerge, then they're able to help brood the new larvae as they're developing, and also take over the jobs within the hive. And you get this rapid expansion of numbers of bees within the colony throughout May. So really by now we should be at peak size. You know, huge numbers of bees in the colony, and basically these are the bees that, when the forage sources come available now throughout late June and July, these are the bees that will collect the nectar and create the honey that provides our honey crop. And then as we go through August and into September, the numbers of bees in the colony gradually decline because the queen's laying rate slows down. They don't want to have so many bees in the colony over winter, and so it gradually declines, and then we come back down to this number of about 10,000. That obviously, you know, varies quite a bit depending where you are in the country, and you know how strong your colony was in the summer, but that's kind of a rough pattern of what happens within the colony. And it's quite important to understand this, because there's a few key things that you need to be aware of, and particularly is this rapid expansion in numbers of bees throughout April and May. And if we have poor weather, or there's not enough feed for the colonies, they can really suffer, because the queen is trying to lay, but they might not have enough bees to tend to that brood, and so then that brood won't survive, and your colony will go backwards instead of expand. So you really have to keep an eye on them in early spring to enable them to develop and build up into this lovely big colony that will provide you with all the honey that you want. Now, what's really interesting about bees is they have a division of labour amongst them depending on their age. So they'll all go through all these different jobs, and what they do depends on the requirements of the colony. And it's really interesting how a colony decides what jobs it needs the bees to do. And it's like a feedback mechanism at work all the time. So if they need comb to be built, then they will stimulate the bees that are of the right age to have wax glands that can produce them some new wax. So basically the jobs that they undergo depend on their age, because there's many different glands that help them to secrete the different things that are needed within their jobs, and it takes different amounts of time for those glands to develop. So between 0 and 6 days, the worker bees will generally be involved in cleaning out the cells ready for the queen to lay into them again, and they'll also be cleaning around the hive, so removing any dead bees, any dead larvae, removing bits of debris, removing any feces that might be within the hive. Generally they're very clean and don't defecate within the hive, but sometimes it's possible. And then as they get a little bit older, their glands in their head will have developed, and these are the glands that they use to produce the brood food. And so they'll move from cell cleaning jobs onto brood feeding jobs. And they'll tend to all the larvae and feed them and generally look after them. They'll also be tending to the queen and providing her with all her high energy food that she needs, and also cleaning her. And then as they get a little bit older, they'll be able to move on to some of the other jobs. So honey processing is a really important job. They'll actually receive the nectar that comes in from the bees that are foraging, and they'll take it and deposit it in the combs, and then they'll maybe provide an airflow by fanning their wings to evaporate off the excess water that helps to ripen the honey. Some of them, as I said, will be involved in wax production. So they have glands in their abdomen that secrete the wax, and if they are running out of space, if the queen's laying rate increases and they start running out of space, then they'll build new comb to provide her with that space. Obviously it depends if they've got enough space within the hive to be able to do that. Hive ventilation is another really important job. So the bees will maintain the brood nest at roughly 36, 37 degrees C. And that's really, critical for brood development. And so they will be monitoring the temperature all the time. And if the temperature drops, they'll huddle together to provide a bit more heat. And if the temperature starts to rise, then they'll fan their wings to create air currents to ventilate the hive. They can also adjust the carbon dioxide levels and the humidity levels by fanning and ventilating the hive. As they get a little bit older, their stings will have developed. They have venom glands within their abdomen, and once these are developed, they can move on to guard duty. And the picture here actually shows some bees at the entrance to the hive, and they're basically just keeping a lookout and guarding the entrance to the hive. Oh, sorry, I went the wrong way. And then as they get a little bit older, they can then move on to foraging duties. And so from about 20 days of age up to about 6 weeks, that's when they become forage collectors. So they'll be collecting either nectar, pollen, or water and propolis. Propolis is a sticky substance that's produced by resin, produced by trees. It's like a resin secretion that the trees produce. And they collect that, and they line the inside of their hive with it. It's like an antibacterial varnish. So those jobs take place at the latter end of their life, and they will probably die while they're actually at work. They tend to die out in the field at approximately 6 weeks of age in the summer, and that's just because they're so worn out. In the winter, they'll live longer because they're not so busy. And so it's like as if they've only got, so much energy, and then when that runs out, they die. So death takes place at approximately 6 weeks of age. So I also just want to spend a minute just telling you the difference between summer and winter bees, because there are marked differences. So in the summer, there's up to 2,000 new bees emerging every day. So if your queen is laying 2,000 eggs a day, then it follows that 21 days later they're all going to emerge. As I said, they live for approximately 6 weeks and they die from exhaustion away from the colony out in the field. And it's the summer bees that, you know, really do the bulk of the work. They're foraging, they're tending the brood, you know, they're doing everything to ensure that there's enough resources to overwinter that colony. Now, come August, September time, the colony needs to think about producing winter bees. So these are the bees that will take the colony through the winter. Now, they're physiologically different to the bees in the summer in the fact that they contain more fat, and this fat is actually like a food reserve for them. So in the winter they can't go out and forage for pollen, and they don't store pollen. It doesn't keep as well as honey. So they have their energy store available within the hive in the form of honey, but the protein store that they need, they store within their own bodies in what we call fat bodies. So these bees will live for up to 6 months to enable the colony to last over the winter, and then they'll rear the first batch of brood in the spring, and then they'll probably die, and then it's up to the new bees in the spring then to take over the colony. So they tend to die of disease and old age rather than of exhaustion out in the field. So the queen will probably still lay a few eggs over the winter, but in all honesty, those new bees, you know, they're only going to be sort of 10 or 20 a day, and they're not going to be able to do a huge amount. So the bulk of the winter bees, the bulk of the bees that will take that colony through the winter are actually produced in sort of August, September time. So it's really important that you make sure that your bees are well fed in August and September, and you know, quite often this can be a time when there is a bit of a lack of feed available for them, so you might have to step in and provide them with some. So I just want to finish now with explaining why we put a dab of paint on the queen, and we tend to mark her with a different colour just because it makes her easier to identify. So if you imagine going into your hive today, there could be, I mean, not all the bees will be in the hive in the middle of the day, because you'd hope that quite a good number of them are out foraging. But, you know, you're going to have thousands of worker bees on the combs within that brood nest. And so imagine trying to look for one queen bee in amongst all those thousands of workers. It can be quite tricky. So we just dab a little spot of paint on her thorax just to make her a little bit more obvious. And we use a different colour paint depending on the year that she was born in. And that then helps us to immediately identify how old she is. So if you open your colony and you see a queen with a dab of green paint on, I know that she was born last year. So we use this little mnemonic on the bottom left-hand corner to remember what colour paint to use in what year. So WYRGB stands for white, yellow, red, green, blue. And the mnemonic is, will you raise good bees? So in years ending with a 1 or a 6, we use white. 2 or a 7, we use yellow. 3 or an 8, we use red. 4 or 9 is green, and 5 or 0 is blue. So any queens that I produce this year, I will be putting a blue spot on. So that's a really good instant way of knowing how old a queen is. Of course, the confusion comes if you buy it from someone who only has one colour paint anyway and uses it every year, and then of course you haven't got a clue. But if you buy commercially and your queen comes with a dab of paint on, the colour will tell you what year she was produced. So that is it in a nutshell. As I say, it's quite a lot of information. And if I can work out how to, here we go, there we go, stop sharing my screen.
That's great, thanks, Linda.
And hopefully we've had some nice, easy questions.
We have some questions. Shall I go through them, Linda? Shall I read them out?
Go for it. Okay,
right. So would 60,000 bees be expected to populate one brood box and 2 supers? That's a question from Roy.
Yeah, you might want more than 2 supers for that number of bees, or actually what is another option is that you use 2 brood boxes. So if you feel that your colony is actually, you know, bursting with brood, and it feels like when you open them every single frame is covered in brood, then I would suggest giving them another brood box. And so you operate on what we call a double brood system then, and that gives them, the queen, plenty more space to lay, and obviously she'll produce a lot more bees, and then you have a really strong foraging force. But you probably would want a couple more supers then, to because if you think about it, when they come in at night, they all need somewhere to hang out and rest, and so actually it's worth giving them a little bit more extra space in the form of another super. Even if you don't feel like they're filling that super with honey, it's still a useful place for them, just to provide them with a bit of space.
Is that helpful, Roy? Is that okay? I just need to unmute you. Are you able to unmute yourself, Roy?
I'll mute now, yes.
There we are, fab.
Yeah, that's very helpful. I put another brood on, and I've also put extra supers on mine because they were so busy. And I was wondering whether that was the right thing to do, but I think you told me the answer was correct. So thank you.
Good.
Excellent. Thanks, Roy. Next question is, could you please explain how they get their propolis from bark, because they missed that bit of the talk?
Yeah, so some trees in particular have a sticky substance around, it's usually around the flower and leaf buds. So horse chestnut is a classic, and if you see the leaf buds of horse chestnut, they're often quite sticky and tacky to touch. And this is what they'll gather, and they'll use that to make propolis. So sometimes you'll see bees coming into the colony, and you'll be familiar with what it looks like when they're carrying a load of pollen and they have a coloured load on their back legs. Well, if they're carrying propolis, they have like a brown shiny substance that's incredibly sticky and really hard for them to remove, and they have to get help from other bees who bite it off their back legs because it's so sticky. And they'll use this to coat the inside of the cells where the bees are developing, because it has really good antibacterial properties. And they'll also coat and varnish the inside of the hive with it. Some people find propolis really annoying because that's the brown sticky stuff that you get all over your gloves that can be a little bit annoying when you're trying to do an inspection. But just remember the antibacterial qualities that this propolis contains and why they use it, and just be tolerant of it. I think it's a marvellous thing.
Excellent. Thanks, Linda. Where can the, oh yeah, that's just to do with the session recordings. The question from Frankie is, where can the session recordings, previous and future ones, be found? Actually, Frankie, if you go onto Cletwr on YouTube, the first session is found there. That's yeah, as one of the, that's been edited as the first beginner session. But it's also, we've provided a link to it on the ABKA Facebook page. So if you're a member of the ABKA, the association, either as an associate member or as a full member, then please do participate in the Facebook page. And there are some other useful talks there as well that you might find of interest. But as far as this beginners series, the first one is on the Cletwr YouTube page. That's helpful. And this one also, once it's been edited, it'll get uploaded to the same place as well. And I'll make sure that we publicise that link on both the via the email distribution list that Mum runs for the association, and also via our Facebook page as well. So, okay. How do bees produce wax, Linda? How long does it take them for them to draw out a foundation frame. So 2 questions.
So bees have 4 pairs of glands in their abdomen, and when they need to produce wax, they'll consume a lot of food, and then they'll hang in clusters to increase the temperature slightly. So they need it slightly warmer than what it will be in the brood nest, just by a degree or 2. And then they'll secrete this waxy substance through the this is really technical, between the tergites, which are the different plates on the underside of the abdomen, and those wax, there'll be like little wax leaves that they'll secrete, and they're pure white and translucent when they're first secreted. They're absolutely lovely. And they'll secrete them, and then using their legs, they'll pass them from their abdomen and pass them through to their mouth. So they'll pick it off the abdomen using their feet, and then they'll transport it through to their mouth, and then they'll chew it up, and then they can take it and put it in the place where they need it to go. So if you imagine thousands and thousands of bees doing this, then that's how come they're able to produce enough wax to draw comb. So it's really difficult to answer how long it takes them to build comb, because it depends on so many things. It depends on them having enough feed, and it depends on them being able to generate enough warmth, and for that there needs to be enough bees to generate the warmth. So if it's early in the season, so sort of May time, and they've got plenty of feed and they've got plenty of space and plenty of bees to produce wax, then they will draw out a frame of foundation in the brood nest in a couple of days, because they want to do it. They need the space to be able to lay eggs, and so they'll very happily draw comb. If you'd put a comb of foundation in last week when it was cold and there was no nectar coming into the hives, they wouldn't have drawn it. It would take you, a couple of weeks to get them to draw that frame, because they just don't have the right conditions to do it. Now, the best way to get drawn comb is when you have a swarm of bees, because they're naturally pre-programmed to draw comb, because they need to build themselves a nest to live in. So if you ever capture a swarm of bees, you'll find that within a few days they'll fill a brood box with fresh new comb, because that's what they need to do to provide their queen with somewhere to lay. So the answer to your question, in a rather long-winded way, is they can build comb very quickly and draw out a frame in a matter of a day or so, but they need to have the right conditions to be able to do that. Helen, you're on mute, which normally I'd quite enjoy.
The dog has been very demanding for a biscuit after its walk. Yeah, there are no other questions unless anybody's got anything particular they want to ask. Lots of thank yous, and very appreciative of the talk, and found it really interesting.
Good, thanks everyone. Like I say, there's a lot of information there, and I really don't expect you all to remember it in one go. I still occasionally have to refer back to the books to remind myself, but it is worth trying to learn it. When you come on to managing a colony, and particularly managing the swarming process, then you need to know what we've just been talking about.
Okay, so the next association meeting is in 2 weeks' time, but the next beginners talk will be Rob talking about how a hive works and equipment, and that's in a month's time. And we make sure that we send the dates out and look out for the notices for that via Cletwr, and also we'll send it out to association members as well. So thank you very much. I hope you guys are finding these talks interesting, and I hope you're able to hold on to the topic even though it's not face-to-face in a room. But then it means that more of you can participate, which is great. So thank you for that. Is there anything else you need to? No, that's fine. Rob, is it okay to move on? You okay? I'll close the call. Yeah. Fab. Thank you so much, Linva. Really good talk.
You're welcome. Bye-bye.
Thank you, everybody.
Bye.
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 Bye.